And yeah, for the curious, quest state was I jumped on to do it, and it was relatively simple. First of all, there was apparently a bug with big numbers. It wasn't one that I particularly was running into, but I looked at the answers I was submitting, and it was in addition. So I was submitting, for example, 20 24 000 plus my answer. And I was like, wait a minute, what if I just submit this bit and it worked? So you can see from the diff, um, I haven't committed it yet. Our numbers went down, so less computation, and I just subtracted the blocks available. So yeah, I was that close. My just brain wasn't picking it up. But that's the past. In here, we're here to talk about the future. Quest 9. So, I'm gonna click this. I'm gonna get Wallaby cranking and going. And we're gonna give it a shot. Here goes nothing. Boom. There's my input. Got it. It's my output. 10. Okay, let's do this. Okay. Input a list of spark balls, brightnesses. Okay, brightnesses. Got this. Cost this equals nodes dot split dot map number. Great. So we have brightnesses. What are we supposed to do with this? 2, 2, 3, 3. Okay, so there's a beetle to thinging. There are 4 stamps available. 1, 3, 5, 10. As few as possible. Okay, so this is like a coin denomination thing. Gotcha. I got this. So it's denoms is right here. I'm going to do reverse. So for cost B of brightnesses, let current equals 0, while current not equal B, and false. Don't want to kill my computer. For const D of the noms, if D const remaining equals it's something minus something else. So it is B minus current if denomination is greater than remaining. Then what do we want to do with this? Let used equals this. Use dot push D, and then current plus equals D, and then congratulations, you did that. Break. Go back to the try. I'm not gonna do calculations here. And then I think we're just counts, right? Minimum number of beetles you used. Yes, I don't even need this. This is mainly a debugging thing. Total used equals 0. Well, plus equals used length. Return total used. And I drop this killer. Okay, that might be working. That might be infinite looping. Looks like it's infinite looping. Let's all be stop. Let me get in there and see where I went. No, is that passing? Might be passing. Come in my input. Shove it in there. Save it. Let's run it once more. Okay, it's. I can't see. Oh, it's unhandled. Great. Okay, so let me breakpoint in there. Let me. Okay, so remaining is 2, right? Because I'm at targeting the brightness of 2, right? I'm not gonna be able to use any of these denominations. Dang it! If denominations less than or equal. Whoops, a daisy. Stop that to run it. Okay, passing. Not passing, but give me a number. Here we go. Boom, I got it. Available stamps change here. Great. Denoms 2. Let's make a copy. I can see there being a change of some kind. In an array, dot reverse, largest to smallest. Solve quest 2. What's the other half of this? Much longer. Okay, exact same thing. I got this. So I'll just use solve quest 2 instead of 1. Let me hit that again so I get the right input. Nope, just give input. Thank you. I'll put you in a moment. Got you. Where'd it go? There it went. Boom. Nope. 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 These are the 2s. Boom. And my input's the same. Slightly different. Let's grab them. This is where things are going to get computationally more. It's probably where my optimizations would help if I did any of them, but I did none. Ooh. Okay, this isn't working. Not referencing the noms too. That would help. Now it's 13 instead of 3. Okay, let's go through each one and see what is being hit here. Come on, part 2. So yeah, the first one I used 2. Good. Next one I used 3. So I'm getting to 41, 30, 10, and 1. I should have used a 25 and a 16. Oh, that's right. We're not just using the biggest one anymore. Interesting. Okay, so what's the way to doing this? It's kind of being like, don't use that one, use this one. So it's kind of like an infinite branches thing for each one. Is there an easy way for me to just increase this? Where I'm like, okay, there's a 30. There's also 25 and 16. Like, just pre-compute all the 2s and all the 3s and all the combinatrixes, basically. All the pairs, all the pairs, all the pairs, all the pairs. Depends on what my input is. We're up into the thousands. Okay, so all pairs of all pair sizes. And then length 2 to length minus 1, basically. That's what we're looking for. For let I 0, well, for let p, it's effectively permutations, which I have an old one for that, so maybe I'll just go steal. I don't remember where I have the permutations bit. Where's the permutations bit? Here's the permutations bit. All permutations, there's no size on this. Nah. Okay, what's the easiest way to go about this then? It's pathing. So for each one, there's a universal where we take a 30, we don't take a 30, we do, don't. We know the ones that get above a certain length. Okay, let's try going for that. Count paths equals an array of what did you do's. I guess first the path is doing nothing. If can take, then do take or don't take. Then it's basically while paths.length cos path equals paths.pop, and then yeah, I guess each one of these has this here, what they've taken, what they haven't. So it is current 0 used empty array. Yep, that's your state for each one of them. Current used, which means you can drop that. You can put these into there. I guess your lets now. And then we find a possibility. We also find a possibility of not doing the thing, so let's not do any breaks. Then what it is, we're basically saying, okay, 2 possible paths, one this way, one the other way. Path stop push. Current used. Yeah, let's not modify this one. And this one's not going down this route, but I can see a way in which we're just going to recalculate this again the next time it goes around, being like, let's try it again, let's try it again. We're just going to be like 5 routes down the path of trying it. Tricky. Okay, let me look at the numbers, see if there's an easier way of doing this. Yeah, just going for the largest isn't the trick here. This isn't a new problem. Yeah, this is already what I'm literally doing. Yeah, but this doesn't work when the denominations are like this. Okay, this is not as simple. Introduce this to different kinds of denominations. Okay, so I have 41. I have options. I can take 30 or I cannot take 30. Let's say I take 30, then I have a path of that. Path of not taking 30, I have a path of that. I think we'll just go for that. And there might be repaths here, but it'll be fine. So let's see, while current's not B, then you do the thing. So that's a cheat there. That while loop's gonna hurt us. We can add an if conditional though. If current equals B, then congratulations, you made it to the end. Found, so it's all of these. Found.push or best equals null. Congratulations. If best is null or best length is greater than used length, and congratulations, best equals used, and then total used, because we're going for the smallest one here. Is this will always happen. We'll at least always find one. Yeah, let's see how that works. Part 2. It's a big calculation. Could have fit that loop. Yeah. Oh, I just say I used it on both, except I don't. Oops. Oh, what's determining me? Yeah, I can see the infinite loop I just hit on. At least it broke, that's good. So I say I'm not gonna use you. I have to not use you forever. So I need another thing of ignoring empty array. And then this is where I have to add it here. Ignoring with an addition of the denomination. If not ignoring. So, well, if it does include a denomination, then continue. Get out of here. Let me also destructure that. There we go. Okay, see if that's a little better. Still a bit hefty. Okay, let me jump on in here then. Let me in here. So yeah, we're dealing with 13. Shouldn't be the two hardest one to break out. Right. So we have it that way. We can use you, we can use you, we can use you. Yeah, so we can try, you know, picking out one of all of these. Okay, how many freaking nominations? Okay, we got lots of them. 10 different things for us using one of each of the nominations. It completely ignores the character. We lose the count of that denomination. So ignoring hits us early. We need to ignore that count for that denomination. Not that denomination itself. Okay, so let's see. Const DC equals use dot filter u equals d. Yeah, so it's not the denomination, it's the denomination count. I feel like I'm really going about this a weird way. Just do the entire thing and just get rid of certain ones. Get rid of random ones. Nah. Okay, let me build my own example right here real quick. And that's part one, so I should stop looking at that. Okay, I'm thinking of like let's say 30 is where we're aiming for. And our denominations are so we have a denomination of 20. But then we also have a denomination of 15. We also have a denomination of 5. So we could do like 20 plus 5 plus 5. That's 3. Or you can just do 3 15s. So let me put these back into here. And yeah, let me go ahead and pass them in. So I should be getting 2. 15 plus 15. That's what I'm thinking. So let me reload window. Let me only target this one. So we have solve quest 2. Let's take them in this params real quick. Denoms. There you go. Okay, let's go away. So, it's an easy example for me to work on. Goodbye, part 1. You're still here. Fine. Yeah, because basically, it's not using one, but then it's also not using one more than once, more than twice, more than 3 times. It's the counts, too. Because if I'm dealing with other numbers, I can see that it's not just ignoring it completely, it's ignoring it for this one instance. Interesting. My brain is not mapping this one either. Okay, yeah, so I think what we need to do is make a thing of this. DID, which is D plus DC. There we go. So now we'll use that. We'll also go ahead and bring this conditional up higher, because this conditional, like, we don't need to say we're ignoring you if we can't physically use ya. So it's basically path of do a thing, or you literally can't do it. So this is supposed to be based on if I choose to not, I didn't have the option to do it. So this is kind of inherently flawed. It's basically this check here, right? So if I know this isn't doing what I want, because it's supposed to be 3 universes, I guess. You go up against something, it's like, I can use it. Great, once you can use it, then do you use it, or do you choose not to use it? So once you can do it, you have a choice. Use it or not use it. So this is the world where you use it. This is the world where you no longer choose to use it. And let's add our ID to these. Yeah, I think that might be unique. Let's find out on our exploration journey. Yep, so we're going to go through all the dominations, of which there are 3. Yeah, there's 3. Right? There we go. I was like, what am I looking at? I'm looking at the target. So yeah, we've never ignored you. We can use you, so we're going to go to a universe where we did, and we don't. Then we're looking at the next nomination. We can use you, choose our universes. Our next one, choose our universes. We're going through it. So we have a few of them. 3 of which solve us? Oh, 3 of us don't get us to our total. So yeah, I shouldn't be tracking around in current. I should be tracking on remaining. It's fine. It's just different math to get there. None of them reach 30 yet, right? So we're going to pop one. That is our ignoring a 5, which that's not the way I wanted to do that. There we go. That's a little better there. I think we need to kind of treat this as a primary heap. So, path sort AB. So it's A dot use dot length minus B dot use dot length, and I want the shortest ones to be where I pop. So let's do some shortest to longest. I need longest to shortest. There we go. And here's where we can do a cool trick up here. If used dot length is greater than best dot length, continue. I'm trying to do early exits, get rid of ones we don't need. Yeah, we're trying to find the shortest one. So if the one I'm looking at is already longer than the shortest one, just give up. I like that. Okay, let's go through it. Okay, let's see this go a little further now. Ah, come on. I'll show. I have to look it with my eyes. Oh, and I just pasted bad stuff. Okay, come on. Let me through. So yeah, I know this is the first one. This one's not too exciting. So not exciting, in fact. Let's go to the next one. Okay, so we have all these. We don't have a best yet. Remaining is 30, because you chose not to do a 5. Yeah. Okay, I'm trying to think of optimal ways to do this. Is this really the way paths sorted? Oh, I went to the shortest paths first. Right. Maybe I want to go to the longer paths first because I can get out of my way quicker or they more quickly terminate. I don't think I'm micro-optimizing at this point, but logically I just want these to get gone quicker. Okay, yep, so we used a 5. This is the 0th one we've used. Yep, we're going to go through all of them. We're going to be able to use everything but a 30. Actually, we'll be able to use either of these. So anything will be optional. Yeah, you can use all of them. Interesting. I'm not seeing any trimming here. So yeah, use 2 5s. You can use another 5. Jeez. Boy, this really sucks until you find one. You're gonna use another 5, you idiot. Okay, let me look at all these paths. Yeah, so I think I'm going to do another sorting things right now. I'm going from smallest to largest. Let's also go to the one where, yeah, so it's 0 or A dot current minus B dot current. Let's put the largest one at the back, which since it's current, not remaining, I want to be this one. There we go. Yeah, I think this is what I want to, I guess, put some more braces on some of these things so I can step in and see when it's going down a little better. There you go. And I really want to look at all the paths. There you go. So I want I wanted 20 to be at the bottom, not at the top. Tag nabbit. Where are my paths? Here they are. Let's look at it again. Okay, there we go. Because now we're going to pull out 20 and we're going to reach an end quickly. And then we're going to try some stuff. Or I think we're going to try 5, right? So we'll be up in the 25s land. Let's go up to it. Look at my paths. Yep, 25 with 2. Yep, so we're going toward the earliest termination possible. Okay, that's kind of what I want. It's not going to be the earliest termination, but we're getting closer to that at least. Let's look at our next paths. Boom, we found our 30. So let's just have some early terminations in here to get that over with. Let's do that here. Next, if current equals B, let's do all this logic right here. Try to get us over with. And then we don't even need to add you, right? We found you. You're done. Get out of here. That's NXT. Allow me to put a breakpoint here. Look at those ones, not those ones. Stop. And the fact of the matter is, well, these ignoring still could take us places, so let's keep that down there. Let's go for it again. Okay, look at my paths. Here we go. Boom. Boom. I'm doing a bunch of ignores. Oh, we're not actually pushing the dumb thing. That would help if I do say so. Look at our paths. There we go. Okay, so now I think we're going to take 25 out of our equation. And we're going to be adding a 5 to it, buddy. So Boom, we found 25. We're adding a 5. It's gonna go into the thing. Our best just got set up. Boom, we have best of 3. Now we're gonna go through this, and as we find things that are longer than this, they're gonna get thrown into the void. I think it's greater than or equal to. So that's optimization. Don't need to rerun it though, because we're targeting 2 for this, right? So we do that. So we're looking at 20. Because our real solution in my world is 2 15s. And what is our current best? It's 3, yep. So we're going to keep looking. We're going to look at the 15s. One of these. Yep, so we're going to pull out the 15s. Yeah, so currently we used a 15. I feel like there's another iterative universe where I've done 15s, where I've done like 2 5s and a 15, but we're not optimizing to, like, I've already seen that in a different order. Okay, and we find it and we succeed. So I think this gets us there, but not the best way I want it to be. So this should get us there too, just not the way I want it to be. Oh, come on. Boy, oh boy, oh boy. Off my game. Okay. I mean, this one still works. Nope, everything's dead. So I'm going from largest to biggest. Maybe there's another way. I mean, obviously, that'll be the worst. Then it's like use as many of these, use as many of these, use as many of these. So if I do that approach, from smallest to largest, I'll get there. It'll just take a long time to get there. That's why I didn't really want to do that way. I wanted to try and be the smart way, but that smart way has got me into a corner. So let's do the hard way. I'm gonna resort them anyway. There we go. So yeah, I think it can just be done all in one. Let's try that. Instead of all this stuff here, we're just gonna be like, okay, you're gone. It's kind of still kind of a path-based system. We're just starting from the other end, the smallest, not the largest. So I just want to use as many of them as possible until I can't use them anymore. It doesn't feel right. Alright, 1, 3, 5, 10. And take the 7. I can just use 7 ones. Great. Or I can just use as many 3s as possible. That's 2 3s. Or then I'll have to use 5s. And with the 10, I'll just use a 10. Okay, let me go through my example. A 30. So for a 30, I could just use all the 5s in the world. Or I could use as many 15s and then I can't use anymore. Okay, so it's basically the starting denomination. Or it's use as many of these as possible. And then I try The problem is that, okay, great, you've used all of those as possible. You still have some remaining. Do you go smaller or do you go larger denominations? I think this algorithm is go for the smallest denomination that will work, excluding the one that you're currently excluding. That one you're currently excluding is only for one round, though. This particular example doesn't last long. Let's make it 35. 15, 15. Well, it's 20 plus 15, actually. Yeah, so this is, I guess, a good example as any. So you're going to use as many 5s as you want. That's like 6 or 7 of them. You're going to keep that one. Be like, great, I could get there in 6 or 7. 15s, it's going to be use 2 15s. And then try and use the higher decimals. So that's the starting denominator. You try to use the higher ones until you can't, at which point you go the other way. Yeah, okay, I think I see that way. And then, yeah, you'll try to use the next higher one. Okay, so it's starting denomination index. And then you just try all the larger ones if you can. If otherwise, you fall back to the small ones. Okay, there we go. For let SD equals 0, SD Austin denons dot length SD plus the starting denomination. Okay, so basically use as many as we can, and then just go forward. So const d equals nons SD if d less or greater than b. Continue. We just can't use you at all, buddy. Const d's. I guess this is a modulo thing. So let's see. If I am 35, where'd my numlock go? 35 modulo 30. Well, it's really divide 30 and then flatten. No, it's 15. That's my example. Usable d's equals. So it's b divided by d math floor. And then let's do let remaining equals brightness, right? Let's get in the habit of using remaining. So basically, if this is a positive number, if there aren't any usable denominations, continue. Otherwise, remaining negative equal usable d's times your denomination. Great, so we've done that. Now we have to get you to go into all the other ones. So it's all the positives and use as many as possible. I just think using as many as possible, it's gonna get us in a situation where like you only were supposed to use one. Again, this is pathfinding effectively. Dang it. Really got my brain in circles here. Right. So, sorry, I just had to put a TL draw. I want to make sure there's client stuff in there. So if we are on trying to get to 30, and we have options 5, 15, and 20. 5, 1, 5, 20. 20, then we can either 5, 10, 15, 20, 25, 30. 15. Okay, let's go for the 35. That one's a bit more interesting. 35. and then another 5, I guess, at the end here. Congratulations. 15, 15, 5. 20, 15, 20, 5, 5, 5. Like there are all these different ways I can build up to this. And then I guess it's 15, 5, 5, 5, 5. So it's all the 5s, and then it's like, okay, you try the next one, all of the smaller ones. 2 of the next ones, all of the smaller ones. And then it would be 20, 5, 5, 5, 2015. Yeah, okay, so I think this, seeing the pattern here, you do all the smallest ones, and then you do all the smallest ones to a point. Well, you do one of the larger ones, and then all the smallest ones. Then 2 of the larger ones, all the smallest ones. Still trying to see how I'd implement this. Because like, these are all the valid ones, but like, how would I choose to try these? I'm kind of falling back into the original idea of trying the biggest ones and then the next ones, but okay, let's just try. So 20 and 20, that wouldn't work. So it'd be 20 and 15, and then it'd be 20 and then you choose to ignore the 15. I'm falling back to that same one again. Dangerous. That's dangerous. Yeah, because basically at every point there are X number of options for me to take. And it's for every input number. That's where the optimization comes in, or the memorization. So if I'm at 20, which means I have 15 remaining, then there are always it's a determinate set number of paths to get that 15 down, of which I should have already calculated, like the shortest path to get that number down. My mind is not liking to map this one. Probably should have chose to do it this morning. But I figured it'll be easy. I'll just knock it out real quick. Right. It's basically a dynamic programming problem at this point. So for all the denominations, boom, those are instant inputs for how do I solve for 20? Use 20. 15, use 15. 5, use 5. So that can be maps to those. And then for each remainder one, there's sub-problems of, okay, what's the smallest I can do to solve this one? And then once I refine them, I reuse them. So that is the function I need to define. Function least to sum to x. X values. Number array. X is a number. There we go. So this is where we basically try all the freaking paths. And this is where it starts to hurt, where we spend computationally, but then we save it in a map that a parent uses for this. Scene record number. There we go. For cost value of values. If value greater than x, can't use that. Don't make a constructor. cost remaining equals x minus value if remaining and seen. Well, hold on. Remaining and seen, then we have possible, well, we've let best equals number max safe integer, seen and seen remaining less than best plus 1, because I'm using a 1 for this, right? Best equals, okay, I'm doing a bit fancy of an optimization here. I just want to see if you've previously solved for that before. And so I'll be like, okay, these are all the best options I have from this point. Let's not go best cost possible equals an array, and we'll just be like, great, we've seen you before. If remaining and seen possible dot push seen remaining, and then possible return math dot min possible plus 1, because I gotta do something. Okay, I like that. There's a universe where it's not in there, in which case else seen remaining equals least to sum to x values remaining, nope, it's remaining values seen. Great. Okay, so our thing here is that our initial call, in order to get to remaining, it's least to sum. Yeah. So our initial call to this will need some stuff. So basically, I'm just looking to test. Come on, fingers. Least to sum to x. So yeah, I'm looking to sum to 30. 5. I have 5, 15, 20. And I have a record of 21, 15, 1, 5, 1. This is what I'm expecting to work. That's not giving me a value. To be, so what is it? To be, what is this one? 15 and 15 and 5, 20 and 15, 2. There we go. Okay, let me step through this because I don't trust it. Yeah, so we have best, which I don't use. We go through all the values. We're like, great, so let's try to find the best I can get to 30. We're not going to see it, so let me jump into there, and into there, and into there. Let's ignore best. I never use it. Great. I can't see half my numbers. Okay, I'm going through my 5. Dang it, I didn't have my things in there. Possible. Okay, I'm looking to make 25. Okay, I'm going to use a 20. I've already seen this because I know how to make a 20. That's 1. So, boom. Possible. I have a path of 1. Going to try and use a 10. I haven't seen that before, so let's recalculate for trying to make a 10. I'm going to get 2 5s out of this. So I've seen a 5. Boom. Ooh, usage of doubles, though. This doesn't give me what I want. That didn't work. I mean, it's going to work because it's 1 plus 1, but it's not working the correct way. Maybe it is. Maybe I'm just being picky about it. Okay, let's let's do some preliminary thing here. If cost gen equals cost scene equals array dot reduce a b1. I think we're starting off an initial object. There we go. Well, not there. There we go. Return, get a net scene. Pass this 5, 15, 20. No, infinity, I goofed up. I'm supposed to use... Nope. There we go. There we go, helps a little bit. Let's use another example. One that was throwing me off, perhaps. No, not that one. Yes, 41. Where'd it go? Here it is. Yep, we're making 41, and we're making it with these denominations. Boop, boop. And it should be a tour. So it's working. I'm not happy with it, but it's working. So let's go for it. Equals gen init scene denoms 2. And then it's basically for each of them least to sum to x b. Total used plus equal sum to x b denoms 2 scene. What's the worst that could happen? Okay, first I guess we'll hit these ones. Boom, our example. Boom, our computational expensive one. Boom, whew. Boy, my brain is not liking this one. To achieve, each needs to split into 2 spheres, but keep the whole effect symmetric. Whatever, that really hurts my head already. Let's put the numbers in the places. Oh no. This is not good. Excuse me. Excuse me. Whew. Yeah, let's try and make a 3 out of this. Okay. I guess I should read this. Split 2 together. Okay, maximum difference between 2 pairs is 100. More steps. What am I looking at? But so we're going to split the first is by using 775 to create 78,000, and another 775 to create 78,000, but not that many. Which sums up to a number within 100 of the target number. Jeez. What? Okay. So it has to be 2 same stamp sums. generate to a number within 100 range of the 1. So this was okay. I'm seeing some pattern here of like this is LCD, GCD, this is some kind of math commonality thing. Yeah, so I see the steps that they got to for these 3. Why 775? We're calculating a different thing too. No, still minimum number of beetles. Hmm. Hmm. Oh, another math one. It's. Whew. It's juggling math at this point. Hmm. Okay. So I'm trying to think of how to get these kind of like down to a doable number. Hmm. Uh, Interesting. Hmm. So we're looking for 2 things that add up to the number generally cut in half, right? So if I take this number, do I have an example? Okay, this is my. I'm looking at the example. Come on, Node. Divide 2 gets me this number, but how do I go from this number to what I'm looking for? I mean, it's lucky it's like it happens to be even, but tomato, tomato. Maybe maybe my optimizations were enough. I can just calculate everything and just use this as a map for what we're doing. Let's see if I lucked out there. Did I put my inputs in? Of course I didn't. Put them in. What's this one supposed to be? 10,449. This one. We'll figure you out. You know, let me bring my part 3 down here. Might as well make the scroll a little shorter. Boop. Okay, so what I want to see if this map is being generated, even though the value is wrong. Maybe I can use the map for something. What the heck did I stop on? What? That's not where my breakpoint is. Oh yeah, but I don't want to go in there. I think everything was out of cache. Ooh, nice. So our recursion just destroyed us. Ah. Okay, so we don't have that happening for us. So I can unwrap it. I'd still hit an infinite thing. Right, it's because I'm brute forcing this basically with recursion to find the best. I need to not do that, which is just optimizing this function here effectively. At least I have part 2 to compare this on. Because once I fix this function, part 2 will be working. It just needs to be faster. And I do think this is the way forward. Because if I have my optimized sums to these, then I cut it in half. And I find the optimized sums to those numbers, like the half number, which is in my mapping dictionary thing. And then it's going to be a lot because it's a raw number, but then I can basically explore within 100, so 50 in each direction. Well, not 50 in each direction because I'm targeting the sums. I guess each of my like A and B would move by a certain degree. Or, I mean, it's not a lot. I probably could just brute force it for the 100 because it's 100 each, and I already have the calculations in the map. So yeah, once I get this map working, maybe I can go further. So let's see about this. So yeah, again, this is unfortunately that least change. Yeah, that's the inefficient way. It might be dynamic programming. Oh, what the heck did I just click on to? Least change. Dynamic programming. I knew it. Coins. So that's number array amount number. Yeah, so if I do this, I'm just like, great, let's just pretend. So yeah, the DP is being here 0 to infinity? No, amount to infinity. So I kind of need the largest one here to reuse. Would I be able to reuse this for all my things? I feel like I should be able to reuse this for all my things because it's building up to it, right? So I need the largest amount. So yeah, that'll be calculated up here. So you don't calculate it there. You don't initialize it there. And you just return what you're looking for. Right. Okay, good. I think this is what I want. But at least to sum to x. It's effectively the same thing, but this, I need the largest value to make my DP. I mean, I like it, but let's min Beatles, basically the same. And instead of gen and net scene, it's gen and net DP. And yeah, I guess these two swapped around. I'm gonna swap them back. There we go. Let's make that function to generate the initial DP. And then what are we going? Amount, number. Come on. 0 equals 0. 0, return DP. It's basically what we needed here. Okay, let's see if it still works. Oh, we just need the largest one here. Sure. Now, you know, let's just take amounts. Congratulations, you're an array of number. I'm just gonna do this here. Boom. Sure, whatever. See if this works. Man, oh no, it's Batman. So that didn't work. Crazy. And code I just yoinked off the internet did not do its thing. I cannot believe it. Okay, so this isn't working. Well, technically I didn't grab it off the internet. I grabbed it from freaking Gemini, so maybe I shouldn't have grabbed it from Gemini. Jeez. Okay, at least I know what I'm looking for. Going to change minimum, blah, 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 blah. Oof. Oof. This doesn't look like the efficient one. Okay, shut up. Give me... I just want the answer. Make sure this isn't the answer. I'm just not using it wrong. Okay, so we'll go through all of them, and then we set each one to the minimum of it. 1 plus it. Don't we need 2 here? I feel like we need 2 here. Because we need... Because we need 2 to compare to choose the smallest one. Which we have min here. But we're always comparing to... off by 1. But that's not what we should be comparing to. I think... Yeah, it's also why we... Oh, we do have 2. It's I always seen this as in 2 explicit loops. We have an I loop and a J loop, but one of them is for of. That's just really confusing. I don't like that. There we go. Okay, I'm liking this a little better. For... Come on, give me my 0. And then, sure. Make it a little easier for us, I guess. yeah, this feels better. At least it's more familiar when I've seen it. Yeah, the only thing I'm not doing here is I'm calculating the DP outside, but let's see what we get, because this one should be relatively achievable. Just make sure. I'm looking here. So we're setting it to the minimum of current. Yeah, well, let's do that. And it is calculating the previous and coin. That's coins I. Yep. Okay, yeah, I see no reason why this isn't working. Guess I'm going to debugging. About 35, which is great. A bunch of random ones we don't care about. And a bunch of nans. Okay, those nans came out of nowhere. Who put the nans in there? This is literally my first step into the debug, which means that the nans have to come in from here. Okay, let's put the breakpoint. Okay, stop debugging, because you hate me. Okay, they were good at one point, and then craziness happened. So we're going to go in there, and we're going to look at this. And yeah, these ones will always be good, because J is within and under the coin amount. Okay, yeah, I don't think we'll have coins ever greater than amount. It's a consideration that could be a possibility. We lucked out in our case. That's not right. Excuse me. So this needs to also include the target. That's probably what's broken this entire thing. Yep, okay, that works. Jeez. Okay, so let's get in that DP, which is the nums 2 and all of our brightnesses. Now that we have that, we can use this function instead of that one. And it should still work for part 2. That's the idea. Still doing a lot of console login. I can drop that though. Okay, it still works for part 2. That was the idea. But now I can. Got to do this again. I can use these for some kind of optimization up here. And then Beatles, I guess. Sure. The point is that I run this, I debug this. I don't care about this function. It does its job. And I have this really big array of numbers. So RIP to my memory. But now I have basically what I have enough data that I can do the brute force with all of these. So it's like this 0 divide 2, right? So it's this number here. And if I look in scene, boom, I have a calculation for that. It's not a good one. Now this is the tough part where I move within 100 to try and find sibling numbers. But I have the hard math theoretically down and dynamic problemed away. So yeah, I do that. I calculate it for the big one, I guess, which theoretically just need to do once for the largest, but good enough, doesn't matter. So I guess I split this into A and B. const A equals B divide by 2. Gotta watch out for them odd numbers though. So math.floor divide by 2. I probably need these as lets because I need to recalculate them. Or, no, I need to reassign them. I can't use a letter B. Oh no. For Bright. Okay, great. So now I have B, which is going to be my other one. So it's just... Well, it's whatever the difference is, right? Because it could be just be A. But if it's floored, then it's going to be off by 1. So it's... what's the larger number? Bright minus A. There we go. So now we have them both. We kind of need to keep trying within 100. But what determines when I move A and B? I guess I can just try within 50 in each direction. So for let O equals negative 50, O plus O equals, that was a really weird calculation. So I'm just gonna do, yeah, sorry, my brain was like, great, O less than or equal to 100, no, 50, O plus plus. Great, it's where it's the same. Const in A equals A plus O. Const in B equals B minus O, right? They both are still moving within the thing. And then I guess we're like, okay, what's your thing? Is it good or is it worse? Best equals number. So we're looking for the smallest. So max safe integer. If seen in A plus seen in B, right? Because seen is our thing. So if it is, I need to store it. Const C equals, right? So if C is less than best, because it's better, best equals C. We did it. And then total use plus equals C, because that's the best we found. Nope, it's the best. This doesn't feel that efficient. It feels like this might be more than 100, which could make it fail. Okay, so that off by 1 could be destroying me. So let's just get 10,000. I got 35,000. I expected to be lower if it were wrong, not higher. It's okay. Let's break point into which problem we're hitting. Okay, best is 5217. Okay, so I'm not really seeing which one I found the best on because I don't have it split. Using 775 to create 78275. Yeah, that's kind of the one I need to follow. So stop that. Put that there. Put that back there. Oh, I'm not doing... I have just two values. And I'm like, great. I'm not doing within 100 of the target. I'm just doing 100 differences. How do I know they're within 100 of the target if I need to calculate them to see that? Huh. Wait a minute. So I have A and B here. A and B add up to the thing, right? So come on. A plus B. Yeah, they add up to there. So I can basically be within 100 less or 100 greater than bright, which is obvious. So they can get further apart from each other. Like A can go to 487 and B can go to 489. They're within 100. That's only a difference of 2. How did 775 show up? Where have I not? Why am I not seeing that one show up? NA 78. No. So I'm generating the number 78213. 213. So I need to go up with this number. Is the split always the same? Because I'm seeing the pattern of, they're not always the same. So they can be, but they're not. So it's basically A can be stationary. It's 100 times 100. That's my possible ranges of A's and B's. But there's the optimized table, which makes all of that a lot easier because we're effectively just doing a bunch of lookups. And we're looking at the difference between the balls themselves, not this secret number which I have lost with optimization. So I think going between them would work. It's like making sure, yeah, so like one goes up, one goes down, and then I invert it, and the inversion doesn't matter because they're arbitrary. It doesn't matter which is which. It's an addition. Okay. So it's basically saying 100 iterations? Or is it 50 iterations? In each iteration we go and move them both around. So let's see if we can say that. Yeah, they're all gone. I'll just rewrite a new one. Let I equals 0, I less than equal to 50, I plus plus. Another potential for an off one, but we'll get to that. So A goes up, B goes down, and then we do the math, and we see if it's better so far. And this will only ever get 100 apart. The first one should be immediate hit, though. Well, not the first one, yeah, because the first one, we need to get to 78213. Which we would get within, that's like 20 away. Then they both won't be 78213, though. They'll sum to a number that is within 100. Do I need a conditional here? I don't know. I could see a conditional being needed here, but it's like, okay, great, you made a number. Is it... Hold on. C less than best. What the heck is... That don't seem right. Oh, that's not A and B. That's the lowest to get to A and B. Right, since I'm only doing this 50 times, they can't drift more than 100. Oof. 35,000. I changed a lot of things here. Why are you the same? Let me in there. Okay, A and B, 78244. That's 213. Wait, why am I looking at 275 and 213? Um, 275 and 213. It's not what I wanted. Also, the distance between these. Okay, we're under 100, so at least we didn't go that crazy. Let's try it again. Put it there. Okay, so we have 5218. What should C be? It should be 775 plus 775. So it shouldn't be this number, that's for sure. Let's just look in our scene. Maybe I don't even have it in here, and that's why we're failing. So scene for this number. That's the problem. Great, so I have numbers in here. They're not... Maybe I'm confused. We made 775 to make this number. 775, 7, and 1. So you used 8 stamps. How did you make this number with that? I don't even see the original thing anymore. This number divided by 2. 78224. We're close to these. We need to find any of them which sum to a target within 100. You chose this number and this number. Yes, that sums up to the thing. Why? Why 78225? No, that's not where they go. You got a big number there. Is this dynamic programming thing not working sufficiently? I can shove this into my thing. That would give me that. Let me just do some other dumb stuff. So 100, that would give me 2, right? That should be 2. Because it's 50 and 50. 100 should be 2. Okay, 50 should be 2. Well, 50 should be 1. You know, all of these should be 1s. 1 should be 1. 5 should be 1. 10 should be 1. Oh, is it because I called it? Okay, I think I'm supposed to call this with the target highest thing. Um, don't know what's working on the other one. We're not gonna question it. Come on, just give me the largest number you. Oh, there it is. Okay, let's see if that. I think I just broke my dynamic thing by calling it multiple times in a gross bad way. Okay, let's see if things look better now. Might be misunderstanding slightly. I literally have a coin of 100. Are we not passing things down? No. No. I'm an idiot. The idiot was I. I'm gonna do it here so I don't become an idiot again. But everything works now, right? Yeah, watch everything just work. I was joking. Oh my gosh. So I could have had the solution for minutes now. So my other thing of like probably the weird 50 loop probably could have worked at this point. Whew. Okay. So I will explain it after. Because that was a toughie. The smallest TLDR is that the trick is using dynamic programming to count the minimum number of coins to generate a sum with. It's dynamic programming. I don't have it memorized. Don't really do this at work every day, so use that and you have an array of how many coins you need to calculate a certain value, the minimum number, and then whatever part 3 was. The trick was, okay, you have two numbers and you let them get further apart, or basically you try every two numbers that can add up to a number within 100 range of the target number, which these do because I only move them 50 times. And then if the minimum number of beetles to get to both of them is below that, or is the best, or is the least, you add that, and you're happy. I will explain this better afterward. Hello, hello, hello. Here we go to refactor everybody codes question 9. So, I'm trying to remember this. Right, okay, yeah, so this is the least amount of change. Refaming. And I forget what this last one is. This last part specifically. Right, trying to find the two that sum up to it the most, or the least, rather. Okay, yeah. So, the actual challenge is you're given a number of numbers, a list of numbers, and you're given a number of denominations, or stamps rather, and you're supposed to calculate the minimum number of stamps used to come up for each of these numbers. So 2, you combine two ones, for 4, a 1 and a 3, 3, 2 1s and a 5. Basically that for every one of these. And then the number you use is your answer for part 1. The same thing, but you have more denominations or ingredients or stamps to build up to it. And the last is allowing you to generate 2 that can sum up to a value within 100 of this particular target number. So they show 775 and 775 to make these 2 numbers, and both of which sum together to a value within 100 of this. So yeah, believe solution I have for this. So part 1, I just brute forced it. Part 2, I tried to brute force it, and then I went and grabbed a dynamic programming solution for this minimum number of change, because that's the base problem. And then for 2, I just used that to calculate the total used, so I used the optimal algorithm there. I think I have part 3 in the middle here for some reason. There you go, which was looping through it and finding the middle, or finding 2 numbers that have the difference of less than 100. So I think, and then yeah, we add best because we find the one that's best. So this one is doing a split. Interesting. So for 1 and 2, they're basically the same problem, just one requires a bit more optimization. For 3, though, it's the same base problem, like calculating this, but then this part is unique. So we'll go for 1 and 2 first, and then we'll go for what could be the 3. Make sure these are all still working. They're not. Oh, I never put the correct number in the box, which 147604. There it is, correcto. Okay, so denominations. First thing, that's a parameter. So let's make that a parameter. I think we might just be able to point 1 to 2. And yeah, we have this. Let me try and look back before I get rid of it all. Yeah, I was trying to use, kind of like pathfinding to determine used and unused one. I was like, nah, that's not really the applicable thing here. At least to some X, which was working, but was very computationally long. Drop that one. This is just making sure it works for a couple of individual cases. Don't nail that. And solve quest 2. So yeah, I think we'll go for this one, because 1 and 2 are the same core problem. Minimum number of beetles. There we go. Minimum total beetles. Stamps. I think quest 1 is where it's angry. There we go. Don't I have an example? Oh, here it is. I just need to put my denominations in here. It is right here. And then, do I reverse it? It looks like I do reverse it. Oh no, so it's built into those other 2. So what we need to do is have this accept. Oh, it's not built in. It's defaulted. Hey, there we go. and then it's sorted. So I don't need to sort it. I'll just get rid of it. Add it there. Yeah, this me. I'll keep these ones around. This one's actually my examples. $30 and $35. Yes, very fancy. And I believe, yeah, we're not going to do the dot reversing. I don't need that. For these ones, I'm just going to undefault these because that's weird. Especially if we're making it as generic as this. And now we'll have complaints, which is what I want. There we go. Okay, pretty happy with that. That should still be good. That it is. Total beetles, so men beetles. Human beetles 4. Yep. And then the generate initial DP array, which is right here. Yep. And then 3. So it's possible, that's the reason this is left commented out, this might have worked. I had it like an off by 1 or something that was dumb. I was like, oh, it was so obvious. It wasn't working. That's why I left this here. So we're going to see if we can get that part 3 to work with this instead of what we have over here. And if we can't, it's fine. That's why we didn't go for it. Nope. Oh, it's off by 2 though. Okay, it's really close. So I think it is doable from -50 to 50. Ooh. Tricky. Zero to 50. We do go to 0. We do include 50. Oh, that's interesting. What's my offset? Oh, right. So A is being incremented, B is being decremented. Am I just on the edge there? Ah, it's down by 2. Ooh. Interesting. Okay, so A is being incremented by this much. B is being decremented. Okay, what if I take the same... Ooh, it's being done first. I'm never seeing the middle. Well, actually, no, I am, because I do hit 0 at some point. So yeah, 0, 1, 2. Yeah. Interesting. Okay, I mean, we can just look at it, I suppose. It's only... Well, it's for every brightness, we're generating 100. I prefer this way, because there's less state that moves. It's more derivative and easier to follow. So really, we just do 50 changes. So if we just do 0 to 50, maybe I'm doing too many. I'm going outside of the 100 range. That's the case. There we go. So when I originally wrote this, it was like, okay, like we have 100, like we have dead on here. We want to go to -50. Well, where'd my 0 go? We want to go to +50 because that's our 100 range. What I was doing here is I was going 150 because this isn't the start and the end. This is how many you go off in each direction. So yep, we didn't want that. If I do want in each direction, it'd be 2 loops. But I like this way better. Which means I like it better because we can make A and B constants. And yes, I know it's all the same for the computer probably. But I like this. What's this one doing? I don't know if you're doing anything here, buddy. Stamps. Let's see if it's doing anything. It was doing something. Okay. So we generate the array. We actually need to run this to populate our dynamic programming array. So, yep. And you know what? Let's call this DP. Keep it going. Let's again a lot of our conditions and setups. There we go. Okay, we have our stamps. We have them sorted. For our brightnesses, which is parsed out. DP, we have this running on our DP, and that returns the minimum. We don't use it in this case. And we go through each, and we see from 50 out in every direction, well, both directions at once, what the best is. So we can shorten this to best equals math.min, the addition of the two, or best. And then now that we have the addition of the two, we can just simply use them instead of variabilizing them. Boop, boop. There we go. Yeah, still need A, still need B. We're flooring it. Watch out for the decimals. Watch out for the non-divisible by twos, rather, but also the decimals. And going through that. So yeah, I think this is good. Let's find the best way to phrase part 3. Find minimum beetles for pairs. For pairings. There we go. Okay, I'm liking this a little better. We have A and B. Can we do the... I wonder if we can just do the inverse here. Because mentally I like that pattern. No. Oh, we're off by 1 again. Oh no. Okay, so they do need to be that way. The reason I want it the other way was just mainly aesthetically, because A is going to the right and B is going to the left on the numerical scale, and I just wanted it to be the other way around. But no. Right, these are just two arbitraries. I mean, obviously they're not arbitrary. I wasn't able to swap them. First and second, I guess. Yeah, I know this works. I don't like it, but it's okay. Do we need this around? We need this for usage there. We need this for usage there. So yeah, we need this. Let's put both of those at the top. If we're gonna do this, let's try and keep the symmetry somewhat. Best. Let's see. Best split, best pair, best least pair sum. Least pair sum. There we go. Okay, I'm liking that. Okay, I might as well name these appropriately. Beetles. There we go. And then, yeah, we don't have, oh, we do have infinities. Okay. Yeah, I guess we'll go ahead and use infinity, which in that case, we're using it. Use it everywhere. Yeah, so with that, that was all there really was remaining to refactor from the 9 solution. Again, the bulk of it is in the dynamic programming solutions to least amount of change to calculate to it. For the part 1 and 2, the denominations or the stamps in this equation is what really changes, which makes this efficient way required. We generate the dynamic programming array of how many to make up for that. We keep reusing that appropriately instead of recalculating each time to give us the minimum number of beetles for that particular beetle. I suppose actually once you've done it, we don't need to keep calling this. We just need to call this for the largest one. So math.max. I think we need to spread on that. Then what's this other one? Yep. Nope. No, that's stamps. What have I done wrong here? Needs 3 and passing 2. What's the third one you need? Well, that's the third dynamic programming array. There we go. And now I should just be able to access DP brightness, I believe. Yeah, there we go. So we just do the calculation literally once for whatever is the biggest number we have, which I don't think... Oh, I'm already doing a max there. So yeah, let's optimize that a little bit. So largest amount plus 1, just to give us the space. And it's not an array of numbers, you're just a number. So cost brightest what? Brightest. It's literally that. Brightest brightness is, there we go. So now that we have that largest number, let's just use it instead. And again, we'll use it again because go for the largest, you'll calculate all the smallest. It's the power of this. I feel like we have to rename something somewhere else. Here it is. Exact same 3 lines. There we go. It should still work. That it does. And if I were to go, we're not going to get much optimization there, honestly. It's just a math max. Okay, so for part 1 and part 2, we do this exact thing. So yeah, we can definitely optimize this a bit. Yeah, the trick, what's changing here is what we do for each brightness to add a total used. So this inner right here, that's all that changes. So let's make a simplified function that does that. Function minimum at total beetles for, and then we don't know what for because that's not what this function does. So it takes the naps and the notes for add to total, well, do the thing. It's good enough. It's a function that does a thing and returns a number. What thing does it take? It takes brightness number dp, which is an array of numbers. That's all it needs. There we go. So now we're going to do this code right here. And then for each of these, effectively we're just doing a reduction, honestly. But we'll keep it like this. Do the thing, B, P, it's good enough. So if anything, yeah, we'll just leave it like this. So we have this. Now let's reuse it. So return notes, stamps, do the thing, brightness. I just need to return DP for brightness, not brightest. Brightness. And that is it for there. Nope. Oh, before initialization. I didn't capture it in my parameter. There we go. Now you have access to it. And now you're happy. Let's do the same for our pairings. Of course, it's going to have more than one line, which is these three. The trick that we return this instead. Call this brightness. And I think we're good. Like a charm. So yeah, we have that one, we have that one, which means these functions become one use. Which makes this function one use, which means we don't need to generate it out here. We can just generate it in the function and then return it instead of just the raw answer, because we never use it that way. So yep, you don't receive it as an argument. Amount, yep, you target it for that amount plus 1. Which means const dp is this, not that. Put an equal sign there. There we go. Beautiful. Drop that unused function. And you know what? Since we're always doing this right here, so it becomes a one-liner. Boom. Let's rename this to brightness. Brightness? The word doesn't look real to me at this point. Okay, I'm liking it. Okay, so do I need the entire array? I do need the entire array. Do I have access to it here? Okay. I was about to just give you the current, but I need the whole. Okay, I'm liking this. Just gotta figure out a good name for that. Calculate beetles for brightness. It's a bit verbose, but it's accurate. Minimum beetles 4, minimum beetles up to that brightness. There we go. Let's give them a little space. Return that, sort that. Okay, now this, let's get rid of that default. It's the third time I've said it. Now this is 9 fully refactored in my opinion. So they both use the minimum beetles 4 helper, which does the sorting, does the parsing of brightnesses, generates the dynamic programming array, basically the minimum number of beetles for every amount up to the target amount. So we generate the one for the target amount and all the ones up to it. We store those results in this dynamic programming array. Then we calculate the total that we are using,
And for every brightness, we call our little function, which takes the current brightness and all of the answers, returns the minimum number of beetles for that particular brightness, adds it up, we sum it up, we're all happy. For part 1, it is literally the number for that brightness. Same for part 2. Part 3, of course, we split it into halves, and then we try and find a pair that within 100, so we just add 1 in each direction, so it's 50, left 50, right? We try and find a pairing that is the least amount of beetles that can be used. So 50 in both directions, you're going to the right, you're going to the left. Keep the least with the men, and we return it. We can do something real fancy here if we want. Return. And then it will start at 0. Nope, it will end at 0. Start at 0 by doing it that way. We can just say total plus, like that. There we go, just threw it into a little reducer. Which technically we're just mapping over all of these, transforming them into the total, and then summing them together. But that's a 2n operation. This is a 1n. Nope, didn't like that. Is that not? Huh. Could have swore that would be right. Did I break something else before this? Why you don't get too fancy. But yeah, that is it from me. Year 9 solution. And that we have done. Always a pleasure.